Good afternoon, everybody. Actually, good morning, I guess, technically. My name is Nathan McMinn. I'm a technical consultant with Alfresco's professional services team, and I'm here to present on some tools for inspecting Alfresco and some techniques that we use in the consulting team to get a better understanding of what's actually going on in this rather complex piece of software that is called Alfresco. Just a little bit of expectation management before we get started. There's a lot of live demo components here with a lot of different tools. Of course, when we do one of these, the expectation is that it's always going to be perfect. It's going to be like the keynote, that everything is going to run smoothly. As I found out in Barcelona when I had some network issues, sometimes the reality is a little bit different. So I want to start out with an overview of the Alfresco stack itself. So this should be familiar to most of you that have worked with Alfresco in any capacity previously. Starting at the bottom, we have the two main components where Alfresco actually is storing content and metadata. And that's the index and the database itself. I've omitted the content store here because that's a whole separate topic, I/O performance on the store. So we're really going to focus on the database and the index components. The next level up on the stack is the JVM. On top of that, we have our application server, Tomcat probably for most of you, but I imagine there's a few WebLogic and WebSphere customers in the crowd. Within the application server container, we have the Alfresco repository, which is the Alfresco web application, and then the Share UI. And then also for any customers on 4 or greater, the SOLR web application that provides tracking and search services. Off to the side on the repository there is a cache tier. So it's really just a component of the web application, but I think it bears separate mention because it actually has some separate tools we can use to inspect and monitor it. For versions that are less than 4.1, of course, that's EHCache. And for those of you that are looking at 4.2, that's changed significantly. EHCache has been removed from the product, and all the caches are now handled by Hazelcast. So what are our inspection targets here? Well, when we start looking at the index, we can look at things like what's actually in there. What are we seeing when we actually index a document? What leucine documents exist within our index? Is it healthy? Has it been merged? Is it optimized? On the database side, we've got things like database query performance, any blocking queries. This can become a problem if you have some long-running operations in Alfresco that may have some tables locked, and that could have impacts on UI responsiveness and other applications that you have running against your repository. Kind of working our way around on the cache tier, we can look at things like cache hit ratios, the cache load, and active caches. There's really some performance tuning targets here, and also some ways to confirm that you're seeing in the caches what you expect to see. On the repository tier, we can look at things like the Alfresco repository statistics, so things around database connections and users. I've got a browser here plugged in, but that could easily be another application making HTTP calls to Alfresco. We can actually inspect those HTTP requests and responses, and there are a number of good tools for doing that. On the SOLR tier, search performance. So SOLR collects some pretty good statistics about what's going on within the SOLR application itself that we can use to first understand what our current performance levels look like, and also possibly determine when we need to add additional search servers or make some changes to SOLR caches to achieve better performance. On the JVM layer, we've got things like JVM metrics, CPU, garbage collection, threads, memory, and all that's pretty basic JVM monitoring that you could get from any JMX application. I want to just make a distinction between monitoring versus inspection. So some of these targets, especially some of the things you'll see around like the SOLR health reports that we're going to look at, they have a performance overhead associated with them. So things that might be appropriate for spot inspections if you're trying to troubleshoot a production issue or you're trying to troubleshoot performance in your extension or your custom application might not be appropriate for long-term monitoring. So when you start looking at plugging in monitoring tools to monitor Alfresco over a long period of time, you need to be cognizant of the fact that those can generate load of their own and may actually make the problem worse. So starting at the bottom, I want to look a little bit at the database. So the examples that I'm going to show are primarily from MySQL, which we have a lot of customers using. But it's important to note that what we're going to look at is available in all the databases that Alfresco supports. So talk to your DBA to find out how to get these statistics. Some of the things that we're going to look at are things like block queries and top queries by frequency or time. And on the MySQL side, there are 2 tools that I use with customers and that they use on their own that we found really, really useful. Inatop and MyTop. Both of these are Perl applications that actually go in and perform some queries against some of the statistics tables within MySQL and generate a user-friendly view of what's going on in there. So you don't actually have to be a DBA to use these, and we're going to take a look at one right now. So the first one I want to take a look at is Initop. When we first sign into it, we get this user dashboard for Initop, which is going to show us some basic statistics, like the number of tables in our database, the number of queries per second, how long the server's been up. I'm not going to dive into all these individually, but I do want to give you a quick overview of what you can get out of this. If we just hit $Gen or help mode for Initop, it's going to show us some of the things that it can monitor for us. So things like the NODB buffers. This is a performance tuning target for MySQL. You may need to adjust these buffer sizes to get optimal performance. Deadlocks, foreign key errors, I/O information can be important, especially on some of the older MySQL driver releases that may have some I/O related issues. Lock weights and locks are typically quite important. So if you're doing something like an ACP import or a bulk file system import, that can actually lock certain tables while it's doing the imports, and that can have a very detrimental impact on the user performance if you have people accessing those applications at the same time that those imports are running. We can also take a look at the query list, which is going to show us all the running queries and things like the currently executing transactions. Another tool that I've used quite successfully is called MyTop. And MyTop just provides a little bit more of a query-oriented view. So it's going to show us all of the individual connections to Alfresco or to the MySQL database and show us what phase they're in. So right now, my repository is not really under a lot of load. So we're mostly just seeing the actual query that's being executed by MyTop. But as these things are going, we can see the queries that are executing, and perhaps more importantly, the number of current database connections. So while we can get some really good information from the database itself, that doesn't ever tell us the whole story, right? Between the database, whatever it is, and Alfresco, we have this abstraction layer. And actually, if you really want to get technical, we have two. We have IBATIS providing an object relational mapping, and then we have JDBC, which is actually the Java abstraction layer to the underlying database. Sometimes what Java sees doesn't necessarily jive with what the database reports. So the database may report that a query has been completed and is closed, but there may still be something going on in the JDBC layer, streaming data back up to the application or something of that nature. So if we want to get a better look at that, one of the best tools we have available to us is actually a proxy driver. There are two that I've used in the past, JDBC Spy and Log4JDBC. Both of these work in a very similar manner. They're actually a separate driver that you configure Alfresco to use, provide a little bit of configuration about what the underlying driver should be, and then these tools sit in the middle between Alfresco and the actual JDBC driver and output some telemetry that we can use to tune query performance. Log4JDBC generally, I've found is a little bit better, and it's also under more active development. I think their last commit was within the last 6 months, which is slightly more active than JDBC Spy. So to configure that, it's actually a really simple config. We would go into our global properties. Let me scroll over so we can actually see that. And notice that I've actually commented out my MySQL driver, and instead I've set the database driver to be this driver spy driver that comes with the Log4JDBC package. We also make a slight alteration to the database URL. In most cases, it's really as simple as putting JDBC:log4 in front of it. And that's enough for the Log4JDBC to pick up which driver it should be using. And of course, you have to have all those drivers on the class path, and the usual rules apply. So when that's actually running, if I was to take a look at my Alfresco log, oh my gosh. I think something's going wrong with my benchmark here. Okay, that's a little bit better. So if we were to actually take a look at this, what we're going to see in our log file as Log4JDBC is running, it's actually going to output every SQL statement that's being executed through JDBC. It's also going to give us how long it's taking to execute. So you can pipe this information into a log analyzer like Splunk or whatever your tool of choice is to actually get a better idea of what types of queries are being executed against the repository and how long they're taking. One of the nice things about this, too, is it shows the actual query with all the token substitution already done. So if you ever have a question about exactly what is being executed, this is a really good way to find out. The next low-level component, once we move on from the database itself, is the index. Just a quick word about the index. This has been a source of confusion, I think, in some of the customers I've worked with. When they move from Alfresco 3.4 to Alfresco 4.0, there's a change in terminology. We're not talking about Lucene anymore. We're now talking about SOLR. Some people have asked, well, does that mean that I have to rewrite my queries? No. SOLR under the hood, it's still Lucene. The upshot to this is that all the same tools that have evolved over the lifespan of Lucene can be used with SOLR once you grab that actual index directory and open up that index. Just a quick word if you're actually looking at using Luke. It's always a good idea to do this against a copy of your index. Don't ever do it against the actual running index. Luke is going to try to open up some of these index files, and of course things like writes and updates to the index will start to fail, and you'll have a colossal problem on your hands. A second issue is that the Luke versions can be important. So Luke versions try really hard to track Lucene versions. So basically there's a correlation between the version of Lucene you're running and the version of Luke that you should be using. If you're just going to open up the index to inspect it, so you want to see, for example, how properties are being tokenized, or if you want to do some query development, Luke's a great tool for that. Doesn't really matter which version you use. If you're going to try to write back to that index, you should definitely make sure you're using the version that corresponds with the version of Lucene you're using, or Luke may just go ahead and helpfully upgrade the index format to a newer version, and when you start up SOLR, it's going to bark at you with some problems. So there's a lot we can learn from the index with a deeper inspection using a tool like Luke. We can look for things like what are the most common terms in our index. We can look for things like document counts and sizes, and that includes both Alfresco document counts and the actual Lucene document counts, which can have an impact on search performance. We can check the current status of the index as to whether or not it's optimized. So when things get deleted from an index, it's really just removing a pointer. It's not actually removed and compacted. Excuse me. We can look at how properties are tokenized. So that tokenization behavior, how an individual text property, for example, is broken down into its component parts and added to the index, is configurable in your content model. And you may want to confirm that it's behaving as expected, and you can do that by looking at those individual properties through Luke. We can also look at what properties are stored. So one of the things that you can do when you're setting up your content model is you can define whether or not a property is actually stored in the index or it's just indexed. In general, it is not considered a best practice with Alfresco to store those properties in the index. There are a few places where we do so for performance reasons, but for custom model development, it's not something that you should generally be doing. And the last thing it's great for is it's a great tool for Lucene query development. Once you have a snapshot of your index that you're working with in Luke, if you're developing queries for your own custom extensions, your own custom applications, it's a very, very handy tool for actually troubleshooting these Lucene queries, making sure you're getting back from the query what you expect and doing so in a manner that is absolutely canonical as far as the index is concerned. And I want to take a quick look at Luke. So what I've got here is an instance of Luke, Lucene Index Toolbox. This is a Google Code project, by the way. So when this talk concludes, I'll have an article up on my blog that has links to all the tools that we've talked about here. I'm actually just going to open up an index that I've taken a snapshot of previously. Oops. And you notice we get a few, ooh, nice. See, I warned you about crashes. There we go. So this is going to tell us just some key information about our index. So how many fields are we actually indexing? Fields roughly correspond to properties in Alfresco. The number of index documents themselves, the number of distinct unique search terms in the index, whether or not this has deletions and has been optimized. It's fairly common for it not to be. And more to the point is this one down here, which is going to show us actually each property that we're indexing within Alfresco. So these should look familiar to you, right? These are all of your content model properties. So I want to open this up a little bit and take a look for our name field, which is just kind of a good example. So we're going to look at the name field for a document. This is just the document name within Alfresco, right? If you'll notice, we have a couple of different name fields listed. So the first one, if we look at the it's kind of hard to see on the small screen, but I'm going to highlight the actual property I want to see and click Show Top Terms. This is going to show us what are the most common terms in the database that are in the index rather, that are in that field. So I've been running some benchmarks against this system, so these are all just kind of test names. We can also take a look at this one that has an underscore after it, and this is particularly useful because it's going to show us how things are actually tokenized within the index. So the name field just has the actual entire name as it was entered into Alfresco. The one with the underscore after it is actually going to show us how that was tokenized and broken down. So if you want to confirm the tokenization behavior for a field in your content model and you want to make sure that it is what you think it is, that's a really good way to make sure that you're going to see what you expect. We can also go through and browse individual documents, do some searches. So this is where we would actually go in to do some Lucene query development on the search tab. We can actually just craft our search expression here, click update, click search, and it's going to show us the results out of that index. Also useful is the explain structure, which can actually show us what operations it's going to take to perform that search. That can be useful in much the same way that explain plan is in a SQL database. So it kind of gives you an idea of what the complexity of that query is actually going to be. Another tool that ships with Lucene, and this is just bundled in the Lucene jar files, is a tool called CheckIndex. CheckIndex just does some simple checks against all the various segments that are in your Lucene index directory. It checks them for consistency, and it checks them to make sure that, that you don't have any current issues with those index files. A couple of caveats: it could take a really long time if your index is huge. And if you read around a little bit about this, you'll see that there's a fix option for CheckIndex. I want to put a big, fat, flashing red warning on this that you shouldn't ever use it. The fix is kind of the sledgehammer of index fix. From what I've read about it, it actually will just delete certain documents from the index if they're corrupted. The end result of that, of course, is that you end up with an index that's inconsistent with what's actually in your repository, which makes the search obviously not really trustworthy. So if you have to go back and restore it, if the check index indicates that your index is actually corrupted or that there's a problem, doing a reindex or going back and restoring from your last known good backup after you check it, of course, is generally a much better strategy. Just not something I recommend doing. So if we can take a look at what that outputs. Let me drop over to my shell again. And this is pointing to the same index that we just looked at with Luke. So when we run CheckIndex, it's going to show us just some basic index statistics. So you know, how many fields out of the various segments that we have in our index. But the most important thing is at the bottom. So if it detects any problems with this index, any corruption or anything like that, it's actually going to output and tell us that there are problems with the index, which is a good indicator that it's time to do a reindex or a restore from backup. Moving up a level to the JVM. The JVM has one really cool feature, Java management extensions. I think that's been talked about at length at Alfresco summits and DevCons for the last couple of years. For people that aren't aware of it, it provides a way to get information about a running JVM. So it basically provides live telemetry about what's going on within that Java virtual machine. Individual applications can extend JMX and provide managed beans of their own that provide ways to either perform actions against the running application. So you can do things like change the log levels of your running Alfresco instance without having to do a restart. Or for the point of this talk, they can expose information that we can use for monitoring and performance tuning purposes. One of the cool things about JMX is how broad the support is. So if you start looking at what you can use with JMX, it has incredible support among Java tool vendors and among just general network monitoring tool vendors. So things like JConsole and Visual VM, those actually ship with the JVM. You know, they're bundled in tools that you can use for just doing some very basic spot monitoring if you have to. More enterprise-focused monitoring tools like Splunk actually have separate JMX plugins, which are just terrific tools they can actually use to poll the repository every so often and build you some information about running trends within the repo. SolarWinds and Wiley Interscope also have similar functionality. So The repository exposes a few pieces of useful information if we're going to look at monitoring and inspecting our instance. Things like our logged in user count, the active and total authentication tickets, and the database pool statistics. One thing to note if you're going to be looking at things like user stats, a lot of custom applications that interact with Alfresco will use a single service account. And you may get some anomalies in the user counts if you're using a single service account to access the repository from your custom application. The repository is not alone in exposing some things to JMX. SOLR does the same. So SOLR can provide us some information about our search performance. Really, the two big ones are our queries per second, which is going to show us what's the current load, and then the average query response time, which can show us how long an average query within our repository is taking. What's cool about that is that those performance numbers are actually across multiple searchers. So SOLR differentiates between an Alfresco query, a full-text search query, and a CMIS query, and we can actually break down those performance numbers individually. The other thing that SOLR provides is a health report. This is one of those items that I talked about earlier that you want to use with care in a production environment. One of the things the health report does is it actually makes a comparison between the transactions that are in the database and the transactions that are in the index. So for very large indexes, very large repositories, this can take quite a long time to run. Some other tools that I use on the JVM tier, the first two are just part of what ships with the JDK, right? So JPS, which is basically a Java version of PS for Unix, just gives us a list of running Java processes. JStack will take all the currently running threads, dump their stacks to a file. A lot of times when you engage with Alfresco support, they'll ask for a stack dump, and JStack is probably the easiest tool to use to get that. JVM top is another one that I found useful. Much like MyTop or InnoTop, it's sort of a top clone for Java. When you first run it, it acts a lot like JPS in that it spits out a list of the running Java processes, their PIDs, their CPU memory usage. But if you run it against a specific process ID, it goes a step further. It actually connects and gives you an internal view of each thread running within your Java application and the load on that thread. The last one is Hot Threads, which actually uses JMX. And Hot Threads is a really cool little tool. What Hot Threads does is it takes several samples of the stack over time, right? And then it compares those, basically the threads that have the highest CPU utilization. It compares them, their stack traces, and then outputs the common parts of the stack. So the idea there being that the common parts of the stack on threads that have the most CPU utilization are probably the quote, hottest parts of the code. Those are the things that are running the most frequently. And especially in an instance where you have custom applications, those can be great targets for further performance tuning. The questions come up before, why would you use some of these tools when a lot of these same things you can collect through JMX remotely? In a lot of production environments, your server might be locked down, right? So you may have a firewall between you and the box, and you might not be able to actually connect by JMX remotely. These are all command line tools. So if you can SSH in and drop a couple jars on the server, you can run these. So when we first run JVM top, that's the first one I want to take a look at. JVM top's just going to give me a list of the running processes, the running Java processes on my machine. It's going to show us what our main class is. In this case, we've got, there we go, 43660 is actually my Alfresco instance. So I'm going to quit the tool and restart it with that particular process ID. And it's actually going to show us all of the individual running threads within our instance, how much CPU they're taking, and whether or not they're blocked by something else. So this can be really useful information for troubleshooting performance problems within a running Alfresco instance. And of course, you don't have to have any sort of admin privileges on the machine to run this. It's just a jar file that uses some of the built-in monitoring bindings within the JVM to actually connect and collect this sort of telemetry. As I mentioned earlier, Hot Threads is another tool that I found really useful. Again, we run Hot Threads against a specific process ID. And it's going to take just a second because it's doing multiple samples. And it's going to spit out, for each one of the threads that it finds in common, the parts of the stack trace that are actually common. So again, this is a really useful tool, especially if you have custom extensions to Alfresco. for finding out what parts of the code are being executed most often and where you may have a target for performance tuning or code improvements to actually get better performance out of your applications. Next up is cache. So as we move up the stack, we've talked about the index, we've talked about the database, some basic stuff about the JVM and some of the running applications. Now onto the cache tier. Cache performance is really, really important for Alfresco's overall performance. When you do a query against Alfresco, and say your query returns 20 nodes, right? Behind the scenes, Alfresco actually executes 3 queries. One for the node aspects, one for the node information itself, and one for the node properties. It then takes the results of those 3 queries and bulk loads those items into the cache. The end result of this is that, say you've got a list of 20 documents from a search result, right? And you're iterating over that list, and you're reading properties for each one of those nodes and doing something with them, like rendering them on a web page or whatever you want to do with it. Those subsequent reads are essentially free if it's in the cache. So for each row in that database, in that Lucene result set, you're not actually hitting the database to retrieve those node properties. When you call node service.getProperty, it's checking the cache first. If it doesn't find it, then it's going directly to the database. Cache information can also be used to verify that your cluster is working right. So that's one of the things that support does. Has anybody ever done the ticket test here to verify that your cluster is communicating properly? So you'll create an authentication ticket on one node and verify that that ticket exists across multiple other nodes. So the cache has a really important role to play within Alfresco. There are 2 main ways to monitor EHCache metrics. One of them is the EHCache tracer job. Now, this just ships with Alfresco. It's in the scheduled jobs context. If you enable that once every so often, whatever the Quartz job interval is configured to be, it's going to run and it's going to take a snapshot of your current cache information, and it's going to dump that out to the log files. That's useful if you're really just looking at a single node, but if you want to try to aggregate statistics across multiple nodes in a cluster, that's a little more difficult to do. Thankfully, the fine folks at Terracotta have a solution for that in the EHCache probes and the monitor application. So the way that works is we actually go into our cache configuration, EHCache custom in this case, and we add a new cache manager peer listener. In here, we're giving it the address of our monitor server and the port that it should use, and whether or not it should actually do memory measurement as well. The monitor server is a separate application, right, that basically runs and it listens for connections from EHCache, and then it receives data from those and it aggregates that data. Shouldn't run that on an Alfresco server. That's really something that you should have like on a separate DevOps box or the same machine that you would use for Splunk monitoring or what have you. When that's running, what we get is a fairly basic console that actually will show us the various cache managers that are currently connected. So this is just a single node environment. If it was a cluster, we'd actually see multiples. And perhaps more importantly is the statistics. Oops, let me see if I can make this a little bit easier to read. The statistics across all of our various caches. So we can see the individual caches that are within our Alfresco instance. We can look at things like the hit ratios, the hits per second. This is also useful for finding out where the most load is on your repository. Typically, the worst offenders are going to be the same ones. So if you're doing lots of reads, node properties cache is going to get hit pretty heavily. It also shows us the total elements in our cache. Now, if you've ever looked at your cache configuration, you know that total elements value is configurable. Why does this matter? Well, if you have a cache that's consistently almost full and has a very, very high hit ratio, that may be a target for performance improvement. You can increase the size of that cache a little bit and possibly get a little bit better performance out of there. The same thing's true of cache misses. So if you have an extremely expensive operation that relies on the cache and you see that the cache misses are extremely high, you may need to rethink your strategy there to see what you can do to take better advantage of that cache. We can also go in and look at an individual cache. Let's see if I can find the one I'm looking for here. Node properties cache, which is actually going to show us all of the individual entries within that particular cache entry. So this is really a great tool for EHCache management. It is a commercial tool, so if you plan on running something like this over the long term, there's a license cost associated. If you're looking at just using it for development purposes or for troubleshooting, I think there's like a 3-day run license is included. So basically you have to restart the server every 3 days, which is kind of a pain. So that's great for EHCache. The question is, what about 4.2? Because in 4.2, we had 2 components, JGroups and Hazelcast. JGroups for cluster discovery and JGroups and EHCache. JGroups for cluster discovery, EHCache for caching. In Alfresco 4.2, those have actually been completely replaced with, with a single product called Hazelcast. Hazelcast is a very similar model in terms of how you would actually go about monitoring it, with a couple of really big caveats. When Alfresco is running in a non-cluster, the caches are actually just, I think they're Google caches, which is basically a hash map with some aging attached to make sure that things age out. As soon as you enable clustering, of course, now that all switches over to Hazelcast. Hazelcast offers a management center that functions almost identically to what we just saw with EHCache. So basically, in your Hazelcast configuration, you tell it where to find the monitor server. That monitor server almost acts like another cluster node, and it monitors the cache performance across that cluster. One of the last things that we get into when we start talking about performance of these applications is your actual HTTP requests and responses. So there's a couple of ways that we go about monitoring this. 2 of my favorites are Charles and Fiddler. Both of these are debugging proxies. So essentially, your requests go through this proxy. It collects information about what was running and when, and can show you over time what the performance of these various requests are and all the request information like the headers and the actual responses and all the rest. They're a little bit different than the browser consoles. So I'm sure most people here are familiar with the tools that are included in Chrome that you can actually use to look at the individual requests that are going across. Those really just work across a single request response cycle. The debugging proxies like Charles and Fiddler will collect information over multiple requests and give that to you in a sort of a timeline view that you can use for debugging purposes. Charles is really my preference. It's also a commercial tool. I think it has a 30-minute run license when you first start it up, but it's not terribly expensive even to buy a commercial license for that. That's available across all 3 of your major platforms. Fiddler was originally a Windows project written in .NET, and there's been some success actually to porting it over to the Mono framework. I don't know if anybody's ever worked with that before. But that's currently in alpha, and I wasn't able to get that running on my Mac, so that's not exactly a ringing endorsement. So I want to actually start up Charles here. Let's see if I can get my benchmark running again as well. So as I'm signing in, that's fantastic. I think I have a problem with my Charles configuration. Well, normally what we would actually be seeing here is a structure of all the HTTP requests that are coming through both my browser, and this can also be configured in such a way that you can intercept requests between Share and Alfresco itself. So if you're ever curious about your Share or Surf application and what requests it's actually making to the repository and what the responses look like, you can actually monitor that through Charles as well. If you're on Windows, honestly, Fiddler is a little bit easier to use. It hooks in at a lower level, so it can actually intercept everything that's going across, regardless of the source. To do Share HTTP intercepts with Charles requires a little bit more configuration that apparently I have slightly wrong. So I want to talk just a little bit about when it's appropriate to do this sort of monitoring. For production, it's really important to have some sort of visibility into what's going on in your Alfresco instance, especially as you start to scale up, as you start to add more users to your application. Nobody here wants to find out that they have a performance problem with a phone call. And proactive monitoring can really give you a much better way to kind of respond to and fix these things before they become issues that pop up with users. So in production, really some ongoing polling of key performance indicators for trend analysis. So we want to look at things like the number of logged in users, the number of database connections, some metrics out of SOLR. And as soon as we're done with this slide, I'll actually show you how we can do some of that. Specific production issue analysis is another reason to dive in and do some monitoring. So if you've already got some production issues, you know that they're there. Putting some specific targeted telemetry around those can really help you resolve them. And the last is configuration verification. So when we're looking at things like popping in and looking at the index, we want to make sure that what we've configured is actually the way it's behaving. And you can trust it, but I always kind of live by that mantra: trust but verify. In test, you've got a lot more flexibility. So you can do detailed key performance indicators during load testing. Some of our most successful large-scale enterprise deployments do this. They put together load tests that accurately model either their user load through share or the type of load that their applications are going to be putting on Alfresco's APIs, and they do some very specific monitoring during the load testing to look for potential trouble before it pops up. Deeper inspection of specific points during development and extension testing. This is where we come back to things like the way the cache behaves within the context of your custom application, or the way properties are tokenized within the index. And the last is just to develop a deeper understanding of Alfresco as a whole. I mean, it's an application that has a lot of different moving parts, right? And when you're trying to troubleshoot something, it can be very difficult to know where to start. If you're going to be developing extensions against the product, if you're going to be running it on a large scale, it really makes your life easier if you understand all the various bits and pieces that make up the product, how they interplay with each other, and what an outage or a problem with one can manifest as in the others. So what to monitor? Some of the things that we'll look at are things like these key Alfresco statistics, JVM statistics, and SOLR statistics. And I want to just take a quick look at Splunk and how we can do that through the tool. Anybody here use Splunk today? Right there in the back. Are you using the Splunk for JMX plugin? No? It's really just a fantastic tool all around. The basic version of it's free, but I think it limits your index size to about 500 megs. That doesn't sound like a lot, but really, do you care what your cache hit ratio was 3 months ago? Probably not, right? I mean, you're more concerned about what's been going on during the time frame you're having a problem. So Splunk has this Splunk for JMX plugin. We can use a very simple XML configuration file to tell it what JMX beans we want to pull, and then how often we want to pull that information into Splunk, and then develop some dashboards that actually give us that information in a pretty user-friendly view. I've already developed all the XML configurations for Alfresco and Splunk, as well as some dashboard configurations. So if anybody wants those, any of the guys that are using Splunk, I'll be happy to share them with you. So on the repository tier, we can get things like our current database connections, right? So Alfresco ships out of the box with a pool size of like 40, which is really too small. That's why in things like our day zero configuration guide, one of the first things we recommend is go in there and change that database pool maximum to the number of application server threads you have configured plus a buffer, usually around 75. If you start running out of database connections, that can have a huge impact on app performance, as application server threads are waiting on the pool to give them a connection so they can service that request. Alfresco exposes the database connections active and idle so that you can get a good idea of what your actual pool size looks like. When this starts creeping up and getting close to whatever you've got configured as the max, it's really time to look at turning that up. It'll also show us things like the current number of logged in users. Apparently, I have 6.431 users. I'd like to know where that 0.431 came from. And the number of live and currently active authentication tickets in the system. So again, if you're using a single service account, this might not give you the most reliable information. But if you just got Alfresco users logging into Alfresco and share directly, it should be fairly accurate. On the SOLR tier, we can look at things like the SOLR caches. So SOLR uses, much in the same way Alfresco does, caches to improve search performance. Those caches can get pretty big, and they have a very big impact on SOLR performance as a whole. A recent addition to the Alfresco documentation is some formulas that actually help you calculate how much memory you need to support the SOLR cache sizes you have configured. So if you're running SOLR, I really strongly recommend you take a look at that. It's a very useful thing. So Alfresco actually has a whole load of caches configured here, and let me see if I can just edit this a little bit and make it easier to read on the small screen here. That should do it. SOLR exposes information about the authority cache, the path cache, document caches, and we can actually look at each one of these and see what things like the hit ratio look like, the total cache hits, inserts cache sizes. This is a particularly important metric because it's going to tell you what your most used caches are. So if you have to reshuffle SOLR cache sizes to deal with a limited amount of memory on your server, it can make sense to pull some out of the caches that are very infrequently used and reallocate it to the ones that have a heavier load. And then things like our cache lookups and cache evictions. Those are useful, but not quite as useful as our actual SOLR telemetry itself. So if we start looking at SOLR, remember earlier I mentioned that we had different statistics across the various searchers that are configured in SOLR. So we can actually see over time search requests per second, and we can break that down across things that are using like metadata search, full text search, and CMIS queries. So it gives you a good breakdown even of how people are actually interacting with your repository, where your search load is actually coming from. And then we also get things like our search response times. This can be a really useful metric for telling us when it's time to look at scaling SOLR, either through adding additional nodes, looking at possibly something like SOLR slave replication to have a separate node for search, or just simply adding more CPU and memory to the box. All of those are valid approaches. We'll also get a little info about search errors and search timeouts, and then our index document count. Although this is kind of a running metric, it can be more useful sometimes to actually get this out of Luke or out of the SOLR web application itself. So yeah, I think we've got about 8 minutes left, and that pretty well wraps up the material. So there's my contact info. I'm pretty active on Twitter, so if anybody wants to reach out that way, I'm always happy to hear from customers, partners, potential customers, community people, whoever. And my blog is at nathanmcminn.com. I publish a good number of articles about Alfresco development. Things like our hackathon results from Boston and Barcelona are published there, so if you're interested in taking a look at some of the community projects that got built over the hackathons in the two cities, that's where you can find it. And I guess that's it. So if anybody has any questions, we've got about 8 minutes left, it looks like. Shoot. Oh, well, we'll wait for the mic, yeah.
Hello. I'm not sure if this is feasible, but if I was trying to diagnose a search performance issue in SOLR, you were showing Luke earlier on, it'd be convenient to sort of test the performance of particular queries. So we could turn on Log4j in Alfresco and actually see the queries being emitted by Alfresco. But those same search queries aren't pure Lucene, of course. They need an element of parsing and translation.
Right.
So when you were showing that Luke tool, I saw that there was the query parser tab there. Is there a way to sort of plug in the Alfresco modified Lucene parser so you can put the request straight into Luke? The reason I ask is because if you put it into Node browser, you've still got all those layers of ORM, database, caching, ACL checks, so you don't know really where the performance issue might start. Well, if you can put that query straight into Luke, you'd know for sure.
Yeah, Luke ships with pretty much the standard set of query parsers that come with Lucene. So I don't know if it's possible actually to plug in the Alfresco parser here or not. As a possible alternative, you may be able to execute those directly through the SOLR web application, because that actually does have all of the, obviously this is the one that's used by Alfresco, so it has all of the appropriate parsers.
Okay, yeah, because I thought that, yeah, as Alfresco being the client to initiate the request, I'm not sure where the parsing took place. I would have thought it was by the client, but I guess not. Yeah.
I'm sorry, what was the?
Speak later.
Yeah, so that would be one possibility. If you're doing pure Lucene query development, when you execute through this, you're actually going to get the query response time for that individual query. So if you could plug in the Alfresco parser there, you could certainly do that, but I've never tried. So that's a very good question, though, and something I would like to pursue further.
Can we get a copy of the slide deck?
It should already be up on the website.
Okay.
Yep, if you look at summit.alfresco.com, it's there without my Hindenburg slide because I added that this morning.
So I have a very limited experience with Alfresco. It basically amounts to I've used Apache chemistry to inject about 50,000 XML files into it on a community edition instance running on my laptop.
Okay, which chemistry project, out of curiosity?
Apache?
Well, there's the
version?
Java client, PHP, Python.
Oh, Java.
Okay.
So here I have this laptop with 50,000 XML files and that I put into it. And Alfresco share seemed like it slowed down quite a bit. So am I potentially looking at a lot of low-hanging fruit there where I can just drastically improve the performance by using these techniques?
I'd have to look at it deeper.
I mean, it's just straight out of the box right now.
Straight out of the box with only 50,000 documents, you shouldn't be seeing a big performance degradation. You know, the first things I'd probably look at there is, are you running the database on the same box as Alfresco? Is it all running on one system?
Yep.
Yeah.
Default JVM memory parameters and everything else.
It's probably just a matter of resources and tuning. You know, generally speaking, we don't really recommend people run the database and the repository on the same box in a production environment, that is. I mean, in development, you can't avoid it, right? But you don't have the same performance expectations in development that you do in prod.
Yeah, it's just a playground right now. Just wondering if there's like a long road of performance tuning ahead of me.
Probably not, actually. I mean, with those kind of loads, you know, even out of the box configuration with enough resources behind it, you know, so running the database on a separate machine from the server, making sure you have a performant content store, making sure the index is on the fastest disk you have available to you. You know, it should be, you shouldn't see performance problems with those kind of loads.
Okay.
For the JVM monitoring tools, do you actually have to be running your application server on a JDK, or can they just be running on a JRE? That's a good question, actually. I've never tried to run Alfresco just on a JRE. I always run on a JDK. So I actually don't have an answer to that. I think the tools that actually bind to the process itself would probably work the same in both cases, but I don't know if JMX is a JDK or a JVM only feature. So, okay.
Anybody else know the answer to that one? It has to be JDK? All right, well, if there's no more questions, we get out 3 minutes early. Oh, wait, we got one more?
We have Alfresco repositories with around 4 million documents. And when we do a Lucene query with a sort applied on any of the date columns, the performance really slows down. Is there any tuning that we can do to?
There are some possible issues there. That's going to be a deeper conversation. So let's take that one offline if that's okay.
Okay.
Yeah, I think that's, I want to loop somebody else into that talk because you're not the first person that's mentioned that.
Okay.
I have an issue. I have some documents that fail indexing. Is there a really effective method for looking at why they would fail indexing?
There's a lot of possible reasons why that could happen. It could happen because there's no way to actually transform the document to text. So, you know, when Alfresco goes to index something, the first thing it does is do a text transformation so they can do the indexing there. You know, I've seen some failed index because they had no path to text, so misconfigured transformers, for example. So that would be probably the first thing that I would take a look at. Thank you. Nobody else? All right. Well, thanks a lot, and let's go get some lunch.